Hey class, this is the fourth video for our ionic bonding video series. And this time, we're going to take those transition metal compounds that we formed the last time and name them correctly. So the first thing you have to do, just like before, you have to identify your metal and your non-metal, and you have to name the metal first, always. Now, just like before, you write the metal's name strictly as it is on the periodic table. So look at this first example. Fe2O3. What's that called? Iron. Now here's where the difference comes between binary ionic compounds and transition ionic compounds. Since we don't know iron's oxidation number reliably, we have to state what it is in the name of the compound. So generally how you do this is you look at the anion subscript, so the 3 right here. But to be specific or to be careful, we're going to look at it a longer way as well. So if there's 3 oxygens in this compound, and we know oxygen is in group 6A, meaning it gains 2 electrons, or it has a 2- charge. If we multiply 3 times -2, we get a -6. Okay, to have an ionic compound, we have to have a neutral atom. So a net charge of 0. How do you balance out -6? You have to have +6. All right, so we need a +6 charge on our metal side. How do we do that? Well, we have 2 irons to work with. So if you only have 2 atoms, you have to have each one add up to this +6. And if you take 6 divided by 2, you'll see you get a 3, which, like I said before, equals our anion subscript, our non-metal subscript. Once we figured out iron's oxidation number, we put that as a Roman numeral in parentheses in between the metal and the non-metal. So iron 3 in parentheses. Now we just have to write the ending. The ending, since it's oxygen, we're going to do the same thing. We're going to change that ending to IDE, and we're going to end up with oxide. So the full name would be iron 3 oxide. Let's try a second one. SNS2. Find SN on your table. Well, that's 10, and we write it just like it is on the table, no changing. Now we have to find out what the charge for 10 is. Now, I told you before to look at the anion subscript, but this is one of those cases that doesn't work. So this is why you use the net charge of 0 technique. 10, we don't know its oxidation number, but we do know sulfur. Sulfur is in group 6A, meaning it has a charge of -2, because it's going to gain 2 electrons to fill its octet. So if each sulfur has a -2 charge, -2 times +2 gives us a -4 for our anion side. So to even out, we have to have a +4 on this side. How many 10 atoms are we working with? Well, when there's no subscript, that means there's only 1. If there's only 1, that entire charge is going to have to be in 1 atom. So our oxidation number for 10 in this case is going to be 4. So in this case, it didn't work out to where the anion subscript was the charge for the transition metal. But for most cases, it will. So 10,4, sulfur is going to change to sulfide. And there you have it. Okay, last one. Let's look at one more. ZnBr2. Okay. Name the metal, zinc. All right, now we have to figure out zinc's charge. Now, zinc is unique because it always has the same charge, but let's pretend like we didn't know that. Bromine, over in group 7A, is going to gain 1 electron, making it a -1 charge, and we have 2 bromine atoms. -1 times 2 gives us a total charge of -2. So zinc has to equal +2. In order to get to +2, we only have 1 atom again, because again, no subscript means 1. So +2 divided by 1 gives us 2. Didn't even need a calculator for that. So zinc's oxidation number is going to be 2, which it's always going to be 2. Zinc 2, and then we're going to finish this off with bromine, but bromine's going to change to bromide. I hope these videos have helped, especially those of you that have been out for extended periods of time due to illness. If you have any questions, please let me know. Send me an email, or if you're on Remind, send me a message on Remind. And I will do my best to get you straightened out on this ionic bonding stuff. It's very important moving forward in the year that we understand and know how to formulate and name ionic bonds.